Good morning, everyone. I just test that we have audio and video connected. Anyone give me a thumbs up?
Yep, we do. I just was getting my coffee. You reminded me when I saw you drinking yours.
Oh, absolutely. I've had one of those mornings. I've got to drop a car off on the other side of Townsville this morning to get repaired. So I had to drive it out there and cycle back to work on my bike. So coffee tastes pretty good.
Oh, I was just in Townsville on the weekend over at Magnetic Island. Beautiful
Lovely.
there.
Yes, the weather's beautiful here at the moment. Yes. Look, I hope you're all well. Let's get going. It is roughly 10 o'clock, just turned. Hopefully you've got your questions ready. I know I've had a lot of comments. The forums are fairly quiet. And so I got a little bit concerned about that and asked people why. And they seem to think because the people in these Zoom sessions are asking all the questions that they would like to get answered. So that's like a de facto pat on the back for you. But at the same time, we don't want to encourage too much intellectual laziness because we really do want people to get on board and get focused on this. Now, some people say I'm focusing a little bit too much on the assessment. Hopefully I'm not doing that. Hopefully the aim is to make that assessment explicit so that there's no misunderstanding about what's required for these tasks and to actually give you resources and tasks that you can take forward with you into a classroom and use rather than give you a piece of paper that will sit on your shelf until you decide to throw it out or use it to put your coffee cups on. So hopefully what we're doing is actually got practical application, and that's why we're talking about not only the what of the assessment but also the how of the assessment. And also giving you some resources and helping you shop around the free resources that are available to you to take forward with you units of study that you can draw on in your pracs. So that's my rationale for doing what we're doing. If it stops working for you, please let me know and we can try a different track. Okay, that's not a problem at all. This is your course and I'm here to actually help work with you in the best way possible. So let's get started. So we started unpacking the chemical sciences strand last week, and you know, and I presented a really simple little activity there that comes from Science by Doing. Even though Science by Doing is targeting the lower primary to year 10, it really is transferable downwards. It's what we call you can backward chain it very nicely into the primary and junior curriculum. And activities like paper, rock and scissors, you know, is one of those great ones, which brings you very much into a discussion of materials and the properties of materials. And from there, we start to develop our linguistic, the lingua franca, if you like, of the science field and science inquiry. We can start to look at what is a misconception, where will it occur? And, you know, for instance, it's really good to ask people why you chose rock instead of paper or scissors. You know, they're getting in context with the properties. And from a little exercise like this, you can easily do your case study, part A. You can actually get people talking about materials. You can get the kids talking about the properties by playing this particular game. And from there, you can note and identify any potential misconceptions that you would explore in a unit on materials. So it's a really, really nice segue into this particular activity. And we'll just keep throwing these up for you. Next week, I'll give you a game of snakes and ladders, for instance, which you can, you know, just basically, I'll put it into the Moodle so you can have access to it and download it. There's, you know, just fabulous little activities you can do that are lead-ins to our inquiry-based teaching. So let's get going. So the activities this week, and please jump in and ask at any particular point in time. We don't spend a lot on the physical and a lot of time on the physical and chemical sciences. People do 3-year degrees in postgraduate studies and then become teachers in these areas. So what we're doing is a nuts and bolts approach, and I fully acknowledge that most of you will be teaching what we call out of area when you're dealing with the sciences. So there's bound to be a little bit of anxiety. You know, you're going to feel like a little bit of a fake. But if we put aside the science understandings, then yeah, we may all feel a little bit exposed. I mean, I'm no nuclear scientist, certainly, and I admit that. And when it comes to science, I have to literally say to people, please explain that to me like I'm a 6-year-old, and then I can get it. But, I mean, the science understanding is only one of 3 strands. So what I'm saying to you is take comfort in that, because the other 2 strands, as a human endeavour, as inquiry skills, this is the stuff of pedagogy. This is what you do as a teacher. So in 2/3 of the science strands, you will be an expert. In 1 strand, you'll be a co-learner. We can all live with that sort of balance. Okay, we can all live with that sort of balance. It's not a sentence. It's actually a really good opportunity to get out there and you know, continue to expand your science understandings. And that's all this is. So we started this week by looking at the curriculum dimensions. And here on the right-hand side of the screen, we can see, the learning areas and how they link very much into, particularly when we look at the physical and chemical sciences. History and geography are two of the strongest humanities links. Mathematics, when we get to chemistry, is a very strong link. And of course, even when we're calculating levers and angles and all those kinds of things, we also get mathematics involved there. In the early years, language is always a focus. Okay, language is always a focus. And in next week's content lecture, which I've already posted, I actually put up quite a few little examples of early years stuff in the physical sciences area, and the heavy focus that actually plays on language. And I'll talk about that in next week's lecture Zoom session. But we can see it's concerned with understanding the chemical sciences, understanding the composition and behaviour of substances. And when we look at the cross-curricular priorities, we're really talking here about sustainability. There are three of them: Indigenous cultures, histories, Asia and Australia and Asia, and of course sustainability. This particular science strand links into sustainability. And the general capabilities, we know there are 7 of them. Raise your awareness of them, because at each level of your F to 10 framework, you're going to be dealing and emphasising different capabilities. This one particularly, this science strand relates to critical creative thinking and personal social competence. In particular, the substrands, 2 of the key elaborations: chemical and physical properties are determined by their structure at an atomic scale. Substances change and new substances are produced when atoms rearrange through reactions and transfer. So it's, 2 really key elaborations there, which can carry you through most of the years. The learning outcomes: locate, describe, explain. The key terms: general capabilities is the one thrown in this week, and of course sustainability. And this is futures-oriented teaching and learning. So for task number 1, we gave you a quick quiz. And this is really just to encourage you to get into the ACARA documents and move around them and know exactly what they're referring to. So obviously the Australian curriculum is ACARA. The 3 priorities were on the previous slide for you, so they shouldn't have been too hard to get. And hopefully all of you will understand the science strands, the 3 of them, and take confidence from that. None of us are none of us are Nobel-winning scientists. We all are very, very good at inquiry, because we've done our pedagogical studies. We're also very good at understanding the human endeavour, because we live in the world and we're active, functioning citizens in the term that Aristotle intended we should be. So the only thing we're going to really need to keep elaborating is our science understanding and developing it in line with our inquiry skills and our efforts in our human endeavour. The 4 science understanding strands, hopefully you know them. Hopefully that came as no surprise for you. And you had no problem sort of nailing those. Which of the following is not a name? And again, we know that explicitly. What we call I'm trying to think of the name of the term. Anyway, I'll come back to me later. But it's planting a wrongful intent. So you can see here we've got 3 positives and a negative. So one's clearly out of step. And the whole aim, as Dennis Goodrum points out in next week's video when you get online, is the ACS is a response to science that's being taught as a body of facts. It's what we call paradoxical intention, actually, yes, where we think, we have something we need to do, but in fact, it's very much the wrong outcome for our learning of this particular science. The key purposes, we're just flicking through these really quickly because they were up on the slide for you on site, and the aim is just to guide your focus, because we don't want you just doing the assessment. You really do need to get down into the trench of these documents and know them quite well, because when you sit down on your placements, obviously you're going to be sitting talking to your mentor teacher, and they're going to assume you've got a working knowledge of these documents. They're going to assume you can move around them and talk about each of the strands, each of the year levels, and each of the elaborations. So it's really important you get in touch with these. And of course, the answers there are for you pretty clear. And the key ideas in the Australian Curriculum of Science. So as you can see, it's a circular model. We've got our strands coming off it. And from there, of course, we've got our substrands. And it's a really nice little diagram. And for those of you who get into the general capabilities, it's also drawn as a diagram as well. So bear in mind, when we're looking at science, particularly in the early years, even probably right up to year 10, we're looking at cross-curriculum elaborations, ones that link into the generic capabilities. And a lot of the examples are some of the reasons why I'm planting you with examples, particularly the primary connections and the signs by doing, is because they make explicit in their lesson sequences and plans, they make explicit links to those documents, to the generic capabilities, and to other cross-curriculum Australian curriculum frameworks. The quiz, this is a really important one. Because we're starting to split down some of the concepts that we're dealing with in this particular strand. So it's really important, you know, the periodic table of the elements, it'll come up next week, we'll have a look at it. You don't need to be knowledgeable of the periodic table. Most of you would be teaching science at an inquiry level, but bear in mind, it's good to come across these concepts and to, you know, to look into them and explore them, to, at least to an operational use, to a layperson's use, because with your registration as a primary teacher, you could find yourself teaching in a P to 10 or a P to 12 school. You could find yourself teaching science at the junior high school level. So each of the different breakdowns here, and a little bit of a rationale. Why is this here? This is here because of this really important column here, the year level. Because when we're doing assessment task number 1, the key area where you can go wrong in assessment task number 1 is to introduce a misconception, and for that misconception not to be part of the Australian curriculum framework for science at your particular year level. And so at the moment, I've got an each student who's emailed in sort of saying they want to look at gravity, at concepts, you know, as they fall. And in ABC Splash, for instance, there's a wonderful little 2.5-minute video done by a British guy in the UK who jumps on and has a look at 2 falling objects. You know, one is a soccer ball and one is a something made of lead. And if we look at the Australian curriculum framework, I mean, the concept of gravity doesn't actually come in until year 7. So if you're in year 3 or year 4 and you're looking to do something about falling objects, then can you still use that? Well, the answer is yes, but you've now got to scaffold that particular concept of gravity. You've got to scaffold that back to the elaborations of physical science at year 10. Sorry, at year 4 or year 3, depending where you're doing it. So those elaborations will be explicit for year 3 and 4. Somehow you've got to make gravity relevant to those elaborations. Now, it's not hard. It's not rocket science. The only thing that's rocket science is rocket science. But to do a good lesson sequence, if you're going to use a more complex or you know, if you like, what we call a sequential block of knowledge like gravity that's brought in at year 7 of the curriculum, and you want to introduce it at year 4, then you're going to need to take the necessary step backs to those elaborations, okay, and do it explicitly so you don't get criticised or lose marks for using a concept that's not embedded in the curriculum at that stage of learning. Anybody got any questions about that particular comment? Because it's one that's come up 2 or 3 times in emails in the forum. No, most people are seeing the sense, okay, and the structure there that's required. Good. Okay, moving on. ACARA, if you haven't been into ACARA, please get in there. Now, most of you know ACARA quite well. You've been on pracs before, so you've been into the ACARA site. It's good to get around ACARA because it's a good guide to Scootle. It's also replicated in Primary Connections and also C2C. Now, not being a member of Education Queensland, I don't have access to C2C. I would love to, but they don't give it to people. And some of you, when you get into schools, if you can, just ask for temporary access or ask for a generic password or borrow a teacher's password to get into C2C and have a look at some of the resources there, because there's a lot of lesson planning stuff in there that you'll be able to use that supports the Australian Curriculum Framework. They're directly linked. Resources this week, I took you through a couple of resources in Scootle. Now, who's using Scootle at this particular point in time? Who's a Scootle user? And does anyone have any preferences or favourite places they go to in Scootle? No, all quiet? Anybody been on Scootle since I put it up last week? Anybody registered?
Yeah, I use Scootle a lot, like with lesson planning and stuff in the past. So yeah, pretty familiar with Scootle.
Brilliant. Yeah, look, it's a go-to. You know, and I think everyone who uses it would agree that Scootle is a go-to. So if you haven't registered yet, please get yourself in there. It's free, and it takes you, the nice thing about it is it links directly to the Primary Connections units. And if you have looked ahead in this course, great, thanks, Amy, thank you. If you have looked ahead in this course, you'll see that assessment task 2 is all about doing an evaluation of 2 science units in the primary connections sequence. So if you do get used to using Scootle, please get in there and register and have a look. Primary connections, we talked briefly about the 5 E's. Science by doing is on the 7 to 10. Scootle is on the F to 10. So basically you've got the full 11 years curricula there, all mapped out for you using the 5 E's model, because both of those resources promote the 5 E's. Having said that, don't limit yourself to the 5 E's. It's just one of many inquiry methods. ABC Splash. Anybody been onto ABC Splash?
ABC Splash is so cool. I love that. It's got some good stuff.
Brilliant. And look, if you like your resources coming being pushed through to you, that sort of push demand resources, ABC Flash is brilliant because it will promote the resources to you. And they also have, if you get into the site, it's got a little window on the right hand side which promotes all related resources either by year level or by area. Twitter, also you can see SIRO Twitter is also fabulous too. If you subscribe to that, because it gives you, recent articles and breaking news about science. So there are some really, really good resources that you can just pull into a classroom at any particular time. ABC Splash, the thing I love about it is the resources are generally really well done. And they just have really good use and utility. So I find them very good for incorporating into science lessons at any level. We're starting to get a little bit serious now when I get to point number 3 here, when we're starting to look at the assessment task. Each week in the Zoom, I try to go through the activities, what comes out of the forums, and also the assessment tasks. And so, for that reason, one of the biggest misconceptions we have is the misconception of a misconception. So we're starting to see, and I said you've had 3 or 4 messages from students wanting to use curriculum elaborations or misconceptions that don't fit into the year of science that their target teaching group. Now, if you're going to build a learning sequence, it must connect to your learners. And so what this table is about is really about going through and sorting chemical sciences by year level. And when we look at the foundation year objects, we've got the first standard 003. Objects are made of materials that have observable properties. And some of the things that you would get students to do in that year level and in that elaboration. Now, in week 4, I've actually posted a video there by Mark Wetherall in part of the content lecture, where he talks about the early years science curriculum having a theme, and that theme largely being observation and prediction. So, it's about what do you understand, what have you observed about what you've what do you understand about what you've observed, and what predictions can you make if this or that happens. So really up to about year 2, he says that one theme goes right across the curriculum. So any of the elaborations in F1 and 2 fit within that particular theme and framework. So this is a really important table. Use it, please, to check where you're working in, what your year level is, and the sorts of things you should be doing. So, for instance, different parts of everyday objects, such as toys and clothes, are made from different materials. So we can see on the materials stream, get to know these if you can. We go right through each of the year levels to give you just an idea of the sorts of investigation inquiry tasks you could be setting up. You've probably got your own ideas.
Can I ask a quick question, Colin?
Yes.
Why is that in science, like the toys one? How is that linked to science?
Okay, there's an emerging, we'll introduce it a little bit later in the course, and some of you will find it quite exciting, but this whole area of STEM, where STEM is, or STEAM, or if you want to go one further, STEAM. So there's right across the world, these sites are erupting where the understanding is that science of itself is just a limited discourse. In other words, it's just one way of looking at the world. And there's, a Nobel laureate coming out of the United States at the moment writing critiques of the scientific method, saying it's really excitement, awe and wonder that drives us. So when we look at this notion of why this exists, and it's got to do with the integration of the curriculum when we use toys, because it's this whole notion of artifact-based learning, that we can take a piece of string around your finger, for instance, reminds you of the fact that, okay, you've got to do your banking by 4 o'clock, otherwise your business is going to have a cash flow problem tomorrow. So that little artifact of a string around your finger represents so much of the real world that you walk around and live in. And this is a reason, the same reason why toys are so powerful, why computer games are so powerful. For instance, I work with robots. Now, kids can actually move a robot around, but these same kids can't relate very well to their world. I've done a lot of work with kids and robots and autism. And they, what kids can do with robots, or kids on the spectrum can do with robots, is unbelievable. What they can do socially in their own lives is quite restricting for them. And that's an extreme example about how toys or artifacts or robots can actually empower a child to engage scientifically with the world. And that's the role that toys have in this curricula. And that's why, really why Science by Doing is so much centered around play-based learning, even for Year 10 kids. It's all about investigations, which are all done, and it can be done as a form of play or inquiry or quest or competition. The whole aim is to turn the learner into a scientist, and to give them, if they can't build a lab, they can't build a world, but they can, for instance, build a robot that can move around a simulated environment and experiment with environmental changes and use scientific concepts and engineering concepts, mathematic concepts to improve and develop that environment. So this connection to toys is a really powerful one. And hopefully that's a short answer to what is a really complex question. Or maybe not such a short answer.
Thank you.
Yeah, but toys have a strong justification, and it's getting stronger and stronger. For instance, at the moment we're looking to get a research grant to work with preschool kids and little Aussie bots, and they have their own program language, but yet they can be programmed using coloured pencils. So we're combining art, creativity. We're giving children control and empowering them to move around their environments and to operate not only in the physical world but also in the cognitive world. And toys make that possible. They're little just cognitive artifacts, and enlighten all of those connections. But please have a look at this. We've done a similar thing next week for physical sciences, because it's really important that your misconception is embedded in a curriculum year level, in a curriculum elaboration, and using activities in this third column that are going to unpack your learning sequence and address that, critically address that, that misconception that you're targeting. Okay, so moving on and going up again, year 7 and 8. And as you see year 8, we start to see it starts to expand. It becomes much more significant, the chemical science, and they broaden a lot at the early primaryhood and earlier secondary and upper secondary levels. And again, at year 9, we can see them chemical reactions, atoms. We start to look at the world from the atomic right through to the universal. We look at scale and size, and there's some great resources there. You can actually view a little video on YouTube where it shoots out from the size of an atom to the size of the universe in 10 seconds, and it's a mind-blowing sort of experience. And it's a great way to introduce the notion of scale, and then bring in, how small is an atom as a unit of study. Chemical reactions, again, a lot of that stuff sits outside the primary school area, but can you use it? Yes, you can. You've just got to scaffold it back to the relevant elaborations in your year level and in your curriculum area. So, sciences and sustainability. It's our key theme, and it's really the chemical sciences linked to, to sustainability as one of the curriculum priorities. And some of the areas where it's identified, we've got here materials, and we go right through to year level to solid to liquids and recycling. And level 4, it gets to pollution in the environment. And level 9, of course, we look at combustion reactions in the environment, which you think things like nuclear power, coal-driven power, all of these different things come into the combustion reactions theme. So it's really, have a close think about how your unit's linking, where it fits when you do your lesson sequence, how you're going to place it, how you write about it. And, sustainability, hint, hint, is the key focus of those priorities, curriculum priorities in the ACS. General capabilities, we talk about them here, literacy, numeracy, ICT, all of these things are embedded in the AC. And the key is to know where they fit in science. And clearly the early years, we know you're dealing a lot with literacy and numeracy. A gap in early years teaching is ICT capability. Now, I know Linda Pfeiffer down in Gladstone, if any of you are local to Gladstone, is doing some great stuff in her STEM lab down there. Up here in Townsville, we're doing a lot of things with robotics and drones. And you may think, for instance, that drones have no application to kids in preschool. Well, think about that till next year when the CQU Easter egg hunt comes on. We're going to drive our own Easter bunny out to local primary schools, and he's going to be dropping Easter eggs, or she, depending who can get into the suit, be dropping Easter eggs around the school ground, and the students will be using drones to find and locate, first of all, the Easter bunny, and then using GPS to locate the Easter eggs. So start thinking again about ICT capabilities and where you as a teacher fit in. We use Lego Mindstorms for kids usually aged, 7 to about 15 in the primary and high school curriculums. But there are other little robots, little robotic cars, little Aussie bots. And again, one gap we've noticed is in early childhood, often, ICT capabilities mean when a child needs to relax or needs time out, they go and play on the computer. They go and play, a little interactive on a computer. And unfortunately, that seems to be the common interpretation of ICT capability in early childhood. So we as teachers can challenge that by introducing different ICTs and getting kids doing different activities and different tasks. Critical and creative thinking, again, fits very much into these areas as well. Personal social capability, the chemical app, and the whole shopping concept there. Now, you don't need to be an elaborate scientist to use the Chemical Maze app. You can actually get students looking at their own pantry. You can get them looking into their own bathroom. You can do a whole term's unit of study on, what is a chemical and where are chemicals located. Okay, what's good for you? Why isn't it good for you? Introduce the notions of health and well-being. And of course, into that comes ethics and ethical understandings. Here is a product that's promoted as really, really good for you. Is it good? Inquiry task. Why is it good? Why is it not good? Intercultural understanding. Okay, comes into all of these areas as well. And from the Q&A forums this week, the aim was to set the forum up and hopefully get you in there trying a couple of these experiments. I keep posting some of them in the weekly content lecture. Where possible, I'll keep posting simple experiments. You don't need a lot of equipment to do them. And this is the whole reason we're trying to post ones. Emulsion, we've got here substances that do not want to sit together. And for instance, I drink soy milk. And when I boil my coffee too much and add my soy milk, I get separation. So, soy milk becomes an emulsion at some stage of heat. Heat has some reaction. Oh, wow, that's an investigation. Okay, at what temperature can I make the ultimate soy flat white? And here we've got separation, a couple of activities. These were actually up on the learning materials for the week. I just can't encourage you enough to get your hands dirty with these science tasks, because that they may seem really simple, but you can set up in your table, in your classroom, you can have 5 tables and you can have a different science investigation on each table. And, over a 5-week period or a 3-week period, your kids can move between tables and complete investigations on each. And then, of course, you've got the ability to put together a little blog or a wiki or a resource or a conference, a little classroom conference where students can actually present their results and explain the research and investigations they've done. So try these yourself. In week 4, I give you a wonderful little one called elephant toothpaste, which is a lot of fun. Kids go nuts when they see that one. So it's a really nice one to tease them through and get them excited about. Has anyone tried any of these or done them before? Not necessarily these experiments, but ones like it.
My daughter they had like a book fair, and they had a book with the crystals, and they had the different, and anyway, we made the crystals for a necklace. And the other thing I found really interesting, I got to Weight Watchers, and I was talking to the leader, and she was telling us a story, and she said, when you lose fat, you actually breathe it out. I always thought you sweated out fat, but she said you breathe it out. And I thought, just then it just reminded me of that would be pretty sciencey concept, isn't it?
That's a really good misconception. Isn't that brilliant? Isn't that brilliant? Yeah, I mean that's.
So you do breathe out fat, don't you? You don't sweat it out. You breathe it out. Is that true?
And it also passes through your body as well. It breaks down. Yeah, but it's a really good inquiry question, isn't it? And even the fact that there would be a percentage that gets breathed out, most of it gets broken down, of course, and gets passed through the body. Same with cholesterol, same with all body byproducts. But if you pose it as an investigation, definitely, it's one of those really interesting shock discoveries, isn't it? Right, we've got Amy saying, I've done the homemade ice cream one and made crystals with my kids. Great, Amy. Katrina, I've done a few in the classroom over the years and at home. Look, if you have your own children, this is a great way to spend a rainy Saturday afternoon, or turn the air conditioner on and have a great summer's afternoon with the kids, especially the ice cream one. If you can make ice cream, terrific. Then you can sit down and enjoy the spoils, and set up a little investigation. Buy 2 or 3 commercial ice creams, put it against your own home ice cream, and, you know, get dad and his mates, or get some friends next door and do a little taste test. Write up the results, graph them, and you know, do a little consumer orientation. So have a lot of fun with these investigations. You know, there's no limit to what you can do. And on that note, please, what I'll do is I'll stop talking and throw over to you guys for any questions you may have about the assessment, or about course content, about anything else that we're doing in the course. Give you a moment to think about it. I'll also have a look at the chat here to see if anyone not connected wants to send in a question. All right, now part of me is in a bit of disbelief. We can't be going that well that the forums are so quiet. Once we seem to get the Weebly done, and sorry, once we've got the site set and fixed, we seem to have, you know, discussion seems to have really chilled down. Maybe I'm throwing too many clues, and maybe I'm forwarding too much information. I don't know, but please, if you can, get the forums active, get them going. There will be a need to peer review when we get closer to our learning sequences, and it would be really good to see you checking with each other. And it may be happening informally, it may not be happening in the forum, which is good. It doesn't have to be visible. But, you know, the forum is a really good activity for just swapping ideas, swapping work, and just posting each other stuff to actually say, you know, here's what I'm doing. What do you think? Any ideas? Anyone done this before? What did you do? What changes could you recommend? How would I focus differentiation into this? Because next week we actually start to talk about differentiation a little bit, because the Australian curriculum for science does allow you to differentiate. And here's where your questions with blooms come in. Not all your learners are going to be the same. You're going to have, you know, a certain amount of kids who are going to be fine. They'll be on their way. There'll be other kids who are going to need in the middle of your bell curve, who are going to need a little bit of prompting and pushing and a little bit of organisation. And then your kids down at the bottom of the bell curve, no matter what you do, you're really going to struggle to get them along. So your lesson sequence is really going to have to break that down into questioning activities and question focus. So your inquiry skills are going to have to be quite structured. So just to point that one out. And looks like we've got no questions coming forward.
Oh, actually, I have one, Colin. I always have questions.
Good, Susan.
My friend and I were like, well, she emailed me and said, does the misconception have to come from the chemical and physical science strands? And I said yes, but then when she was looking, she said, I can't see anything that says that it's from the that it has to be. But it does have to be, doesn't it? I mean, I'm sure it says it here on the task sheet. No,
it doesn't actually. And the reason being, and I've actually answered this in the forum, because I had the question 2 or 3 times.
Oh, sorry.
Yeah, and I'll just explain it again, because some people obviously still aren't getting that information. It's so early in the course, and we haven't actually done anything related to the strands of physical and chemical science when you came across your first assessment item. So we're only really looking at the chemical and physical strands now. And that doesn't give you enough ammunition, enough background to get in there and use those 2 strands for that particular assessment item, because we're doing a learning sequence. So,
sorry to interrupt, it says here, through research, select a scientific concept taught in either chemical sciences strand or physical sciences strand of the Australian curriculum that is commonly misunderstood or poorly understood. It actually says it on the task sheet.
Does it? Okay, well, we've actually broadened that out.
Oh, okay. Well, I mean, I got this from the unit profile, so maybe there's like an actual, that was before I could find a task sheet on.
Yeah. Yeah, I'd say that's the case, Susan, because what we do is we get feedback every year. I mean, obviously, this is why we ask you guys for feedback. And one of the feedback sessions when Linda Pfeiffer taught the subject was that this was a real limitation, that students felt that assessment's due at the end of week 6. We've only got 5 teaching weeks, and we've only just started chemical and physical sciences. How can they possibly develop with any confidence a learning sequence in just those 2 areas? So,
okay,
for that reason, we opened it up in response to feedback from you guys.
So the task in the unit profile doesn't match up to the task that is being handed out. So I'm actually must be looking at the wrong thing.
Go to the one on the subject side, and you'll see there, and also in the forum it's explicitly written that you're not limited to physical and chemical sciences. I mean, it's great if you can do that, because that's the whole purpose of this this course, but some people are reluctant to take that leap of faith. Others, for instance, have taught, as we've seen here in the chat and in your own comments, have used some of these activities before, so you're quite confident in working with them and writing them up. But not everyone's in that situation. So for that reason, we have, in response to that, broadened the area. But assessment task 2 is strictly physical and chemical sciences. Yeah. And there's the old schools, you know, that says that if you're doing physical and chemical sciences, you know, there is a suggestion there that it's better to do them in your assessment. And also what you do in assessment task number 1 is going to feed into assessment task number 2. So, you know, if you're doing it in the same curriculum strands, then, you know, it's obviously going to be helpful at that level. But not everyone, as I said, is in that position. So, you know, for that reason, we've given a little bit of ground there. We'd rather see some good resources come through and a useful than a stressful experience. So, yeah. Any other questions or comments? But I will check that unit profile, Susan. Yeah, I mean, they closed 6 months before the subject. So maybe that hadn't been updated. So I didn't have this subject 6 months ago. So that's what I'm saying. But definitely, I'll have a look at that and try and reconcile that gap. So, but
yeah, I guess having, like, you know, busy job, kids, I try and get pretty organised early on in the term.
Yeah,
and I think maybe that's what's happened, is that it hadn't been there at the beginning when the term opened. So thank you.
Yeah, not a problem. Well, if there's no more questions, what I'll do then is I'll hit the record button on this and post it to YouTube and put some links online so that other people can benefit from your questions and your input. But please, I just encourage you as much as possible to start playing with some of these experiments. You'll know and notice that there's a definite drop-off in the amount of writing activities that I'm asking you to do in each weekly task. And the reason is to encourage you to do some doing. You know, the whole pushing of science by doing. You will learn more from doing and developing your inquiry approach as a teacher than you will be from reading from Loxley and from Gregson. They're good textbooks, but they're theory. And you become a good teacher of science by playing with slime and making elephant toothpaste and doing emulsion activities, making ice cream, building crystals, all these kinds of things that we do.
Oh, well, that's really funny that you say that, because my 7-year-old said, "Can we make slime this afternoon?" So maybe I'll say, yes, I have to. It's part of my homework.
Well, that's a great one. All right. Look, thank you all. And again, we'll talk next week. Week 4 content lecture is up already. And I'll put week 5 up early, because I know some of you are self-pacing and moving ahead quickly and don't want any surprises. So week 5 talks about assessment. And that closes the circle on that first task so that you can actually build in some diagnostic, some formative, and also some summative assessment into your lesson sequence, which of course we'll be looking for as assessors. All right, thank you very much and speak to you next week.